Hello, welcome everyone. Today we are going to discuss some extra questions on continuity, and this will be lecture 4 on this particular topic, continuity. And these questions are very important from the point of view of your board exam or some entrance. Okay, today's discussions, this will be the question 1. Okay, what is the question 1? Determine the value of k if fx is equal to log 1 plus ax minus log 1 minus bx by x, and if x not equal to 0 and is equal to k, okay, that fx is equal to k if x is equal to 0 is continuous at x equal to 0, then we need to get the value of k. Okay, now we know that if a function is continuous, then the left hand limit is equal to right hand limit is equal to functional value. Therefore, first we'll calculate the limit, okay, at x equal to 0. Okay, limit x tends to 0 fx. Okay, limit x tends to 0. Okay, so fx will replace this log 1 plus ax minus log 1 minus bx by x. Okay, just first let us calculate this. Okay, so this is equal to limit x tends to 0. So separate the two terms in the numerator. Log 1 plus ax will divide by x, okay, and minus is there, so we'll take limit in both the function, that is log 1 plus ax by x and log x, limit x tends to 0, this is log, okay, 1 minus bx by x. Okay, while finding the limit on log 1 plus x by x, we are going to use a known formula, that is limit x tends to 0 log 1 plus x by x. We are going to use this, and we have discussed about this formula, so which is e is equal to 1. Okay, so here if we manipulate the term ax in the denominator, like limit x tends to 0 log 1 plus ax, and this term also, which is going to make ax, right? Because this is x and this has to be x, and here x is ax, so denominator x will be multiplied by a, and so we'll be multiplying the numerator also by a. Okay, fine. Now this particular term, the right hand side, this particular term, that is second term, so this minus sign, okay, just we make it plus, because here is you have seen that here this term, x term is minus bx, so therefore we need a minus sign there, so we can just write plus there, okay, we can write plus there, and that minus, okay, that minus we can just write it this minus x, okay, we can just make it minus bx, so it's log 1 minus bx, right? What extra term you have written here? This instead of minus you have written plus, and that minus we have written with this. And in the denominator, what is extra here? B. Only b is extra, so you multiply the numerator by b. So you can just use the formula log 1 plus x by x formula. So this is for x approaches to 0, limit x approaches to 0, this is equal to 1 into a, so this is equal to a, and plus similarly for limit x tends to 0, okay, that is log 1 minus bx by minus bx is also equal to 1, and 1 into b, right, this is equal to b. So we got the limit of the function as a plus b. Now, okay, let's see what is the functional value. Okay, functional value of the function, what is given, that fx, this fx is equal to k for x equal to 0. That means f0 is equal to k. So let's move to the next slide. Now f of 0 is equal to k, and we know that if the function is to be continuous at x equal to 0. So the limit of the function should be equal to the functional value. Therefore, just k is equal to a plus b. So this is the first answer. So k is equal to a plus b. So let us move to another question. This is also an important question. What is this? If fx is equal to x minus 4 by mod x minus 4 plus a for x less than 4 and a plus b when x is equal to 4, and x minus 4 by mod x minus 4 where x greater than 4 is continuous function. It's given that it is a continuous function, alright, then find the value of a and b. Okay, so what will be the simple steps? Since this function is given to be a continuous function, it's continuous everywhere. So therefore, we can definitely say that function is at, continuous at x equal to 4. Okay, now at x equal to 4, let's calculate the left hand limit and right hand limit separately, because here this fx is equal to this for x less than equal to 4, and fx is equal to x minus 4 by mod x minus 4 x greater than equal to 4. So have you seen this two term x greater than 4 and x less than 4? But therefore, we need to calculate left hand limit and right hand limit separately. So let's just calculate left hand limit, right? Limit x tends to 4 minus, because we are calculating the continuity at 4. So limit x tends to 4 minus fx. So x approaches to 4 minus, so x is less than 4. X is less than 4. The function can be replaced by x minus 4 by x minus 4 mod x minus 4 plus a, right? Now, most important is that when x is approaches to 4, that means this x is slightly less than 4. So when this x will be less than 4, so what is the mod x minus 4? So mod x minus 4 will be negative. So what is the next term? X tends to 4 minus, so this will be minus x minus 4. Okay, the mod x minus 4 will be negative. Why? Because according to this limit, x approaches to 4 minus means you are approaching 4 from the negative side. So x is less than 4. That means this x minus 4 will be negative. So mod x minus 4 will be minus x minus 4. So this is x minus 4 plus a. Right? So you can cancel this two terms. So if you cancel this, it's minus 1 plus a. So what will be left out? It's minus 1 plus a. So remember this. So this is the this is the value of the left hand limit. Okay, this is the value of the left hand limit. So just calculate the right hand limit now. Okay, right hand limit. Limit x tends to 4 plus. Okay, limit x tends to 4 plus. What is given for right hand limit? X minus 4 by mod x minus 4 plus b. It's given as plus b. So you can just check that value. So on the question, okay. So it's given. I will check this. So this is x minus 4 by mod x minus 4. So here plus b, right? Plus b is missing here. So please correct this. So it should be plus b, right? It should be plus b. Okay. So let's just move to this. Okay, plus b. Now limit x tends to 4 plus. So x approaches to 4 plus means x is greater than 4. So x is greater than 4 means here x minus 4 is greater than 0. It's positive. That means this x minus 4 is positive. So therefore, when x is positive, mod x is always is equal to x. So what is the next term? X minus 4 will be, just we can remove the mod sign because x minus 4 is positive. So it will be x minus 4, right? Okay, and plus b. So you can just cancel these two terms, right? This is, you can cancel this. You can put a bracket there, right? Okay, you can put a bracket there. So this two will be cancelled out. Okay, this two will be cancelled out. So it will be 1 plus b. So therefore, right hand limit, remember this, right hand limit is 1 plus b. So we can just write, therefore, right hand limit is equal to 1 plus b, and left hand limit, just we have calculated, left hand limit is equal to 1 minus a. We got this, Okay, no, we got this one is this one minus 1 plus a. We got it minus 1 plus a. And also let us check also f4, right? What is the functional value? Let us see the functional value of the question. Okay, so what is the functional value? For x equal to 4, the functional value is what? A plus b. So let's move ahead. Okay, the functional value is, right? Functional value is a plus b. So how many equations we got? We got the 3 equations. This is 1, this is 2, and this is 3. We are just going to solve this. Okay, and if we solve in this way, okay, that 1 plus b, right? 1 plus b, that is, okay, we can just solve here. Alright, say right hand limit. Right hand limit is 1 plus b. That right hand limit is equal to the functional value a plus b. So therefore bb is cancelled out. bb is cancelled out is equal to a equal to 1. Done? A equal to 1. Also, when you can compare. So you are comparing the right hand limit and the functional value. Similarly, you can compare the left hand limit and the functional value. Now, we can compare. Now, the left hand limit minus 1 plus a. You can just compare with the functional value. What is the functional value? Functional value is a plus b. So you can just cancel a. So b is equal to minus 1. So these are the values of a and b. A is equal to 1 and b is equal to minus 1. These are very important questions from the point of view of the board exams. Okay, we'll just move to next question. That is question 3. What is this? That prove that like these questions are very common, like it's there in the exemplar also. If you have done it, just obviously you have seen this question. Prove that fx is equal to 1 minus cos x by x squared for x not equal to 0 and equal to 5 for x equal to 0 is discontinuous at x equal to 0. So that is the question. It's indirectly given. You don't need to check. Like it's given that you need to prove this function is discontinuous at x equal to 0. So since it's given as x not equal to 0, we don't need to calculate separately left hand limit and the right hand limit. Just we'll calculate limit, okay, at x equal to 0. Limit x tends to 0, f of x, okay, limit x tends to 0. So this fx will be replaced by 1 minus cos x by x squared. Now in case you check the form of this particular function for x equal to 0, this will be 1 minus 1 0, and this is also 0. So it's 0 by 0 form. Well, just it's a determinant indeterminate form, 0 by 0. Well, just most simplest indeterminate form. Just we're going to remove the indeterminate form. Okay, here we are not using L'Hospital because I'm just solving this initially from the point of view of the board exams, and where it's necessary to use L'Hospital, and if the questions are mainly meant for entrance, then we'll be obviously using the L'Hospitals. Okay, 1 minus cos x will be using the formula 1 minus cos x 2 sine squared x by 2. Very simple formula, and x squared. But remember this, after using this formula also it's 0 by 0 form. Now we need to use more steps for this. Okay. Right. So limit x tends to 0. So I just repeat the steps once, like 2 sine square x by 2, right? 2 sine square x by 2, okay, is the denominator is x, fine, okay. So this is the question, and right, this was the question. Okay, we are doing these questions. Next, these questions, right? 1 minus cos x by x squared. So denominator is x squared, not x, right? Denominator is x squared. So just, okay, denominator is x squared, fine. Denominator is x squared. So we have gone to a right, fine. Denominator is x squared. So 2 sine square x by 2 by x squared. So limit x tends to 0. Okay, so how to simplify this? So to simplify this, that sine x by 2, okay, and this 2 I'll just write here, sine square x by 2, I'll just write sine x by 2, sine x by 2, fine, sine x by 2, but sine x by 2, then this x, I'll just write x with this function, I'll write 1x with this function, fine, x square, so here angle is x by 2, I'm just going to write x by 2 there, so if I write x by 2, I need to multiply by 2, so there also, similarly, I'll just manipulate the denominator, so in place of x, I'll be writing x by 2, I'll just multiply to 2, fine, so what I have done is, 2, this is 2, sine square x by 2, this is sine x by 2, this is sine x by 2, and x square is splitting as x into x, and since the angle is x by 2, so I should write this also in the form of x by 2. So in case I manipulate x to x by 2, I need to multiply by 2, similarly it's done. Okay, now we know limit x tends to 0, sine x by 2 by x by 2 is 1, and sine x by 2 by x by 2 is 1. So therefore, what is left out? It's 2 by 4, right, is equal to half, right? 2 by 4 is equal to half. Let us check the functional value. What is the functional value of the question, right? What is the functional value? So functional value is given as in the expression, okay? We'll take the functional value, what is given, right? Okay, what is functional value? X equal to 0, the functional value is given as 5. Okay, the functional value is given as 5, but we got the limit is equal to half. So therefore, the limit of the function at x equal to 0 is actually not is equal to the functional value. Therefore, this is discontinuous. So since you can just write f of 0 is equal to 5. Okay, and limit x tends to 0, okay, at x tends to 0, fx is equal to half. Therefore, the limit of the function is not equal to the functional value. Therefore, this is a discontinuous function at x equal to 0. Okay, so let's take one more question. Okay. Right. We'll take these questions that find k if fx is equal to under root 1 plus kx minus under root 1 minus kx by x, and where x is greater than equal to minus 1 less than 0 and x is greater than equal to 0 and less than 1. Okay, is continuous at x equal to 0. Find if it is continuous, find the value of k. Okay, now first of all, let's just at x equal to 0, we'll just find out left hand limit and right hand limit. At x equal to 0, fine, at x equal to 0, so left hand limit x approaches to 0 minus f of x, limit x tends to 0 minus fx, okay, fx. So here x approaches to 0 minus means x is less than 0, so x is less than 0 comes here, x less than 0, so fx will be replaced by this function, that is 1 plus kx minus 1 minus kx by x, right? So it's a very simple sum. We know the method how to find a limit of such function. What I'm going to do is we'll rationalize the numerator. Okay, so we'll rationalize the numerator. So we'll just multiply both the numerator and denominator by under root 1 plus kx plus 1 minus kx. We'll just multiply it, and we'll multiply the same term in the numerator. So root 1 plus kx minus root 1 minus kx, and multiplied by root 1 plus kx plus root 1 minus kx. So we'll be using a minus b and a plus b formula. So therefore it will be 1 plus kx minus 1 and minus minus it will be plus. So it's kx. Done. So we can just remove this. 1 will be removed. Okay. What's the next step? So can we go to the next steps? Right. You can just move to the next steps. Fine. Okay. Limit x tends to 0 minus. Fine. Limit x tends to 0 minus. So what will be left in the what will be left in the numerator? Kx plus kx, 2kx, and denominator will be this. Okay, 2kx. Okay, 2kx, x, and 1 plus kx, right? 1 plus kx and plus 1 minus kx, right? This will be left out in the denominator. Okay, 1 plus kx plus under root 1 minus kx. This will be left out in the denominator. So it's 1 cancel out, kx is 2kx, right? Okay, 2kx. Fine? Yes. Okay, 2kx. So you can just cancel this xx. Right? The moment you cancel xx, this 0 by 0 form will be removed. Okay. Now can you put the limits now? So if you put the limit x approaches 0, so it will be equal to 0. This will be also equal to 0. So what will be left out? Let's see. The numerator is 2k. Fine. And denominator is this will be 0. Its root 1 is 1, and this is root 1 also 1. So it will be equal to 2. So just get the value of the left hand limit as e equal to k. Okay. So just find the right hand limit now. Okay. Right hand limit. So limit x approaches to 0 plus f of x. Right. So limit x tends to 0 plus fx. So what is the value of fx? Let us check the value, right? Let us check the value. That means the function is equal to 2x plus 1 and x minus 1. Okay, 2x plus 1 and x minus 1. Okay, 2x plus 1 and x minus 1. So if you substitute x equal to 0, it's not in a 0 by 0 form. If you substitute 0 here, so it's is equal to 1 by minus 1 is equal to minus 1. So you got the right hand limit is equal to minus 1. So we know that it's the question given as, right? What's the question? Find k if this function, okay, is continuous at x equal to 0. If it is continuous, left hand limit and right hand limit always has to be same. Okay, so therefore, so here k and this left hand limit is equal to k and right hand limit is equal to minus 1. Therefore, you can write k is equal to minus 1. Fine? Okay, so this is a very simple questions. So let's move to next questions. Okay, right? So we'll just take another questions, alright, that is fx equal to 1 plus mod sin x to the power a by mod sin x, okay, where x is greater than minus pi by 6 and less than 0 here, and x equal to 0, then fx value will be b, and x is greater than 0 and less than pi by 6 if fx is equal to e to the power 10 twice x by 10 3x. Okay, this is also a very important question, right? Okay, so how to find the value of a and b? Okay, it's given. Most important, you need to focus on that. Like, what's the question? It's continuous at x equal to 0. It's given continuous. So since it's given is continuous at x equal to 0, left hand limit, right hand limit, and function value all should be equal, and we have to equate to get the value of a and b. So you can just start with any limits. Like, we'll just start with, since it's given x less than 0, we'll just start with this left hand limits, right? Okay, limit x approaches to 0. So approach of this particular question will be a little different than the questions we have done now. Okay, limit x tends to 0. Okay, so 0 minus, right? So you can replace this function, that is 1 plus mod sin x. Okay, sin x to the power a by mod sin x. Then, okay, so in one step you can just simplify this. Limit x tends to 0 minus. Okay, this can be written as 1 plus mod sin x. Fine, and to the power 1 by sin x, 1 by mod sin x, and whole to the power, you can just write a. So this exponent a by mod sin x can be written in this form, right? So why we need to write in this way? The moment you write in the form limit x tends to 0, 1 plus mod sin x to the power 1 by mod sin x, here in this place, okay, in this place we can use a very important formula, alright? Very important rule of limits. What is that? That is limit, we know that limit x tends to 0, okay, 1 plus x to the power 1 by x. So we know there is a limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Okay, if this term, that is second term, is approaches to 0 and the exponent is 1 by x form, okay, and where x approaches to 0, then this value is equal to e. So we can use this formula in this place. Therefore, limit x tends to 0, 1 plus mod sin x to the power 1 by mod sin x. This will, because for x approaches to 0, we know that sin x is equal to sin x also approaches to 0. So therefore, this can be replaced by e. Okay, so if we replace this one by e, so you can just write this value. This value we can write as, okay, we'll just move to okay, next page. Okay, if we take the limit, we can just write this is equal to e to the power a, right? So the limit will be e to the power a. Why? Okay, because if you see that limit x tends to 0, this is equal to e. This value is equal to e. Only e to the power a will be left out. Okay, therefore this gives us e to the power a. Okay, we just find out right hand limit now. Right hand limit. Okay, limit x approaches to 0. Okay, limit x approaches to 0. It's given as. Let us check this. What is given? Okay, e to the power 10 twice x by 10 3x. Fine. Okay. E to the power 10 twice x by 10 3x. So how to find this limit? So we can just use this limit. We can take the limit and this function's limit x approaches to 0. These are the questions. In fact, we have discussed previously also. Limit x approaches to 0. Okay, so we can just write limit x tends to 0. Okay, 10 twice x. Okay, this is 10 twice x. We can just write twice x. Fine, twice x. Just we can divide 10 twice x by twice x and we just multiply by 2. Similarly, 10 3x. We can just divide by 3x and we can multiply by 3. Fine. So this x and this x will obviously cancel out. So since we are introducing a 2 there, so we are just multiplying. Similarly, this 3 and 3 will get cancelled out. So but we know like limit x approaches to 0, 10x by x is always equal to 1. Right? So therefore, x approaches to 0, 10 twice x by twice x is equal to 1 and 10 3x by 3x is also equal to 1. So this gives us e to the power 2 by 3. We got the right hand limit is equal to e to the power 2 by 3. So you can just write once that left hand limit is equal to e to the power a, right hand limit is equal to e to the power 2 by 3. And let us check the functional value. Okay, let's go back to the questions. What is the functional value for x equal to 0? That means f0 is equal to b. Okay, f0 is equal to b. f of 0 is equal to b. So you can just club all this value together and you can find the value of a and b. Okay. So we can just find out what is the value of this one. We can just compare this. That is the b. We can compare right hand limit and functional value. So b is equal to e to the power 2 by 3. b is equal to e to the power 2 by 3. Then if we compare this one, these two values, that is e to the power a is equal to e to the power 2 by 3. So this gives us, if you compare this, a is equal to 2 by 3. Fine. So b is equal to, if you compare, b is equal to, because if the function is continuous at x equal to 0, this value e to the power a, okay, e to the power a should be equal to e to the power 2 by 3. Should be equal to b. So you want the value of b. So you can compare this. b is equal to e to the power 2 by 3. b equal to e to the power 2 by 3, and you need the value of a. So you can compare these two values. E to the power a equal to e to the power 2 by 3. So a is equal to 2 by 3. Okay. These are the questions that for this particular video. Okay, and then I'll be uploading another video consisting of similar questions. Okay, taken from different books. Okay, from exemplar or extra books. Okay, which will essentially help you for your preparation for board as well as for entrance. Okay, and thank you so much. And okay, and try to share the video, and so that we can get the motivation for uploading more videos. Thank you so much.